Hi guys, welcome back. Remember, you should have watched mole video on the different particle types to begin with. And now we're moving into mole video referencing the mass. So as a quick reminder, we learned in our last video that if we have 1 mole of something, if we were to actually count them up, we would have 6.02 times 10 to the 23rd of those somethings. Okay, it is actually impossible for us to count that high. We could actually do a unit analysis problem to figure out how long it would actually take us to count that many things. And let's not even go there right now. All right. So, what we're going to do then is we're going to be thinking about, well, if we can't actually count things one at a time, can we actually do counting by weighing? All right, so the example in the how big is how big is a mole video, they talked about how you typically don't go and order 43 slices of salami from the deli counter. You would order a quarter of a pound of salami from there. And so what we're going to do is, well, what mass would we need to have so that we knew that we would have 6.02 times 10 to the 23rd particles of, whatever substance that we have. Okay, so the question then is, if I have 1 mole of a substance, how many grams will it be? And I tell you what, 1 mole of a substance, it depends on the substance, will have a completely different mass. Just like if you had 1 mole of bowling balls, you have 6.02 times 10 to the 23rd bowling balls. If you had 1 mole of cotton balls, you have 6.02 times 10 to the 23rd cotton balls. Their masses are not equal if we think about their mass. However, they both have 6.02 times 10 to the 23rd if we're actually counting them. I think sometimes people get confused with what a mole means, is because a mole is always the same. It doesn't matter what you have, a mole is always the same. But a mole is always different as well. So it's always the same if you're counting how many things you have. But if you're concerned about weighing them or what their mass is, the mass will be different. So that's what we're going to do now, is how are we going to determine what is the mass of 1 mole of a substance? So first of all, let's get a definition. Molar mass, by definition, is going to be the mass of 1 mole of a substance. And where we're going to determine what the mass of one substance is we are going to be using the periodic table. And what we're going to be using from the periodic table is the atomic mass. So I have a copy of a periodic table down below, and you'll notice right here, if I look at carbon, that the atomic mass of carbon is 12.01. So if we do as an example, carbon atomic mass equals 12.01 from the periodic table. How easy is this going to be? If I have 1 mole of carbon, then, you know what? It is 12.01 grams. So if I go to a balance, and if I get on my balance 12.01 grams, and I know what I have in my dish here is carbon, then I know there are 6.02 times 10 to the 23rd atoms of carbon in that beaker. Because remember, 1 mole, I don't care what I have. If I have 1 mole of something, I know I have 6.02 times 10 to the 23rd of that something. And according to the periodic table, if I have 1 mole of carbon, I have 12.01 grams of carbon. Okay, so we could do that for any substance on the periodic table. Is we know if we have 6.02 times 10 to the 23rd atoms of it, we now know what the mass of that is, because the periodic table's atomic mass tells me that. So what would I do then? I'm going to go ahead and go below my periodic table right now. What if I had a substance, though? What if I had 1 mole of carbon dioxide and I wanted to know how many grams is it? Or in other words, what is the molar mass of carbon dioxide? The number of grams in a mole. Well, carbon dioxide's not on my periodic table, only elements are. But here's the thing. If I had 1 molecule of CO2, there's going to be 1 atom of carbon and there's going to be 2 atoms of oxygen in every 1 molecule. Well, if I had 1 dozen molecules of CO2, then there's going to be 1 dozen atoms of carbon and 2 dozen atoms of oxygen. Well, what are we doing? We are chemists. We're going to use a chemist's counting unit. So if I have 1 mole of CO2, it will have 1 mole of carbon in it and 2 moles of oxygen in it. And I can go ahead and I know how to figure out what the mass of 1 mole of carbon is, and I can figure out what the mass of 2 moles of oxygen is as such. So here's what I'm going to do. For CO2, if I think about carbon, I get 12.01 grams of carbon, and this is what I'm getting from the periodic table. And what I'm going to do is I'm going to multiply it by 1, and this comes from the subscript in the formula, meaning I get 12.01 grams of carbon in every mole of CO2. For oxygen, if I go to the periodic table, it's 16.00 grams of oxygen, but the subscript there is a 2. All right, so we're taking that subscript there, and therefore this is 32.00 grams of oxygen. So if I add all of this up, 1 mole of CO2 then has a mass of 44.01 grams of CO2. Another way of saying this is CO2's molar mass is 44.01 grams per mole. So as a reminder, if I have 1 mole of something, I always have 6.02 times 10 to the 23rd of those somethings if I'm counting them. If, on the other hand, I want to count by weighing and I wanted 1 mole of something, what I need to do is I need to reference the periodic table. Okay, nice job.